class. For today's session, we will discuss Computer Laboratory 8 assignment number 4, design and implement class modeling. This assignment is to create analysis model class diagram, and in the next assignment, assignment number 5, we are having to implement the design model for a vision analysis model. So we are creating class diagram in both the assignments. First assignment number 4 having the class diagram which is for analysis model, and assignment number 5 having the class diagram which is used for designing model. So first we will discuss the theoretical aspect of the assignment. So check here, design and implement analysis model, that is class diagram. What is the aim? Analysis of the system, identify project of enough complexity with the 4 or 5 major functionalities, its stakeholder actor, and prepare problem statement for the system. So here, important thing is already throughout the CL8 lab assignment, we have considered our project of online grocery system. We have identified all the classes, the actors, use cases, activities of the online grocery system in our previous assignment. So I will be continue with the same project online grocery system to design the class model. We will discuss some of the theoretical part of the class model here. What basically analysis is? Analysis is the first step of OMP technology, that is object management technology. It's concerning with devising a precise, concise and understandable and correct model of the real world. Before building anything complex, such as a house, computer program, hardware and software system, builder must understand the requirement and the real world environment in which it will exist. The purpose of OO analysis is to model a real world system so that it can be understood. To do this, you must examine the requirements, analyze their implications, and restate them rigorously. You must abstract important real world features and then defer small detail units later. So basically, the success of analysis model states what must be done without restricting how it is done. So it avoids implementation decisions. So here we can see that in analysis model, we are hiding implementation decision. Only for the analysis purpose, we are implementing the class model. But analysis model is the base for design model. So here we can check some of the analysis model where there is some system conception, generate request, user, developer, manager. These are the actors, those who are generating different requests. And as per their request, we define our problem statement. Like user make the registration, then we purchase online. It may be a grocery or any other item. So problem statement gives us that we need to define a system of online grocery. Then what are the building models? Depending upon user interview, domain knowledge, real world experience and related system, we focus on the models, that is how to develop a website for online grocery system. What are the requirements? What basically the content of this website? How uh, the admin website should handle the queries of the customer. So it comes under domain and application analysis. Basically, after domain and application analysis, we develop class model, state model, and interaction model. So in the real world system, the problem statement must be understood. Perhaps if the process of constructing a rigorous model of the problem domain forces the developer to confront a misunderstanding early in the development process while they are still easy to correct. So basically what is class modeling? First step is analyzing the requirements to construct an class model. The class model shows static data structure of real world system and organizes it into workable pieces. It has the relationship. Class model proceeds the dynamic model and functional model because static structure evolves easier for human understanding. Basically, as per the human understanding, we need to construct class model. Going further, what are the steps to construct class model? Identify classes, prepare a data dictionary, identify associations, that is the relationship between classes, aggregation, identify attributes of classes and links, organize and simplify classes using inheritance. We need to show the organization of classes in the class diagram using inheritance. Verify the access path that exists with the queries. Iterate and refine the model and group classes into modules. So what are the constructs for the class modeling? A class represents entity with a given system and which is encapsulated with the functionality of the entity. So the export by the classes are the classes methods. Apart from the functionality, a class also has the properties that reflect unique features of a class. The properties of the class are called as attributes. A class is comprising of the attributes and the methods. In UML representation, class is represented as a rectangle containing three compartments. The top part contains the name of the class. It is printed in the bold and a center. The first letter is capitalized. Then the middle part contains the attributes of the class and the left aligned and first letter is lowercase. The bottom part contains the methods of the class which class can execute and they are also left aligned and first letter is lowercase. So these are the standard intentions to draw a class with a three compartment, top, middle and a bottom. Top is name, middle is attributes and bottom is operations performed by that class or methods. Then here we can list in class name, list of attributes, list of methods. So in a design system, the classes are identified and grouped together in a single diagram which helps to determine the static relations between those objects. So this design splits into number of subclasses. Here we can say sample is a circle. What are the attributes? Radius and the center of the circle we are defining here with the point 0, 0. And what are the methods? We can calculate area of the circle, circumference of the circle. We can set the center of the circle and set the radius. So this is the example of a class circle. Then we need to define the different relationship for drawing the class diagram. So basically these are the logical connections found on the class and the object diagram. Relations are first is association, which represents a static relationship between two classes along with its multiplicity. So an employee can have one primary address associated with it, but can have multiple mobile numbers. So either one to one or one to many multiplicity exists, association exists. So associations are represented by a thin line connecting two classes. Association can be unidirectional or bidirectional. Multiplicity defines how many instances of the class can associate with the other class at a given moment. So here we can define like 0 instances, 1 instances, exactly 1 instances, then 0 or more instances. So class can have 0 or more students. Or one to many, a flight can have one or more passengers. One to star or 0 to star. In unidirectional relationship, it shows the source object can invoke methods of destination class. So in Java, it is possible to example can be instance variable of source class referencing destination class. So here we can take a relationship like patient and ward, and we can show it's a unidirectional relationship. Patient having a patient name and class is a word class. In the bidirectional association, each of the class in the relationship refers to each other by calling each other methods. So in the same example, we have a car class and inside customer class. So both are refers to the role and depicted by instance of a variable in the code. So this can be having the both patient and ward relationship. Then another method of association is the reflexive association. A class can also associate it with itself using reflexive association. This may not make sense at first, but remember that classes are abstraction. So employee class could be related to itself through the manager's role. So manager is an employee and manager is a separate class. So instead of creating two different classes, we are showing here reflexive association for a class that employee class reflexively associated with the manager class. So it is the class associated with the itself. So it does not mean that the class's instance is related to itself, but an instance of the class is related to another instance of the class. We can create instance of manager class as well as instance of employee class. So employee can be manager of another employee instance because the relationship role of managers has a multiplicity 0 to many, and employee might not have any other employees to manage. So 0 to many. Then in the multiplicity relationship, we can show the relationship usually described as A has a B. So showing the multiplicity. Again we can see here 0 to 1, no instances, or 1 instance, exactly 1 instance, 0 or more instances, 1 or more instances, and we can define the multiplicity between the classes. Then after association, another relationship is the generalization. It is known as is A, indicates that one of the two related classes, that is subclass, is considered to be a specialized form of the superclass and is considered as a generalization of the subclass. So an example, tree generalization is a form of biological classification. Human beings are subclass of children, which is a subclass of mammals. So we can show the relationship of inheritance using class diagram. For showing the generalization, a hollow triangle shape of the superclass is used in human representation. We need to define an empty triangle on the superclass end of the line. Normally, inheritance is a type of a relationship, parent, superclass, and a base class relationship we need to show. So here, employee, doctor, nurse. This kind of a generalization you can see here, and this is the empty triangle. You can see here, hollow triangle to show the generalization relationship we use. Then another relationship in a class diagram, aggregation. So it is a has a relationship. Just remember, generalization is a relationship. Aggregation has a relationship. So this relationship highlights that whole is made up of its part. So whole is destroyed, the part is still remain. In UML, it is represented through hollow diamond. with the diamond symbol pointing towards the whole. So aggregation is hospital and address. You can say it is the aggregation relationship. So here we can observe that the address is a part of, it has a, hospital has address. It is a compulsory part of hospital. Hospital comprised of address, has a, hospital has an address. This is composition relationship. Sorry, this is the aggregation relationship. In composition, it is a type of aggregation, but important is a whole or part relationship where if the whole is destroyed, then the part cannot exist independently. So important point about composition is that the part at any point in time can have only one owner. A person can be an employee of one company at any point of time due to contractual obligations. That person cannot hold dual work authorization. So the composition represents a filled diamond. Aggregation, you can check here. It is a hollow diamond for a hazard relationship, but composition is the compulsory relationship. It is a filled diamond, you can see here. Because hospital must have a ward. Without ward, hospital does not exist. So composition is compulsory here. Then another relationship is the realization. This relationship between a class and a interface. Realization is equivalent to the implements. A class implements interface. So this is very straightforward implementation. Unlike the generalization, in this case arrow is dashed. So we are using the generalization, but it is a dotted line indicates that it is not the generalization, it is realization, as array list implements the interface known as list. It is the interface implementation. Then for the dependency, sometimes some two classes are very weak. They are not implemented with member variables. So rather than they can implement as the function arguments, the relationship between a bill and order is dependency. Bill is depend on order. So without order, will not exist. So it is the dependency relationship. So this is regarding the class diagram. We can take the class diagram. Here, sample example is given for the hospital management system. You can draw different classes like hospital, ward, patient, address, account department, employee, ICU, general ward. You can make here the generalization relationship between ward, general and ICU, male ward and female ward. Employee, you can categorize into doctor and nurse. So you can show here generalization relationship. Also, you can show here the aggregation relationship. Patient has a address. So this kind of a class diagram can be implemented in analysis model. Here you can observe we have only written the attributes of the class. We haven't mentioned its implementation and the methods we did. Only the generalized form of the class diagram is written. So let us discuss how to draw the class diagram using star UML. So already we have discussed our online shopping system. So we have here one model in star UML, that is online system. Already we have drawn the use case model if you observe. For online grocery shopping, we have here our use case model. So our registered users are there, customer are there, customer register on a website, login, customer browse different products, get the discount, customer have different methods like net banking, card, COD, wallet, UPI. Then customer will get the invoice, update stocks, delivery of product, generate a report. In the secondary actors, we will observe your admin and delivery agent. So for this particular use case diagram, we will try to map the analysis class model. So basically in the analysis class model, to start with, you go to your model, online grocery system, right click and say add diagram, click on a class diagram. You will get a class diagram main here. You can put a name class diagram online grocery on GS for remember. So online class diagram for grocery system. On the left side you will get class package interface, enumerations and all the details and also relationship of the classes. To start with the online grocery system, we need a customer class. You can say here as a user we have defined our customer class. So for class customer, we can write a class and then the relationship. So when you draw class diagram, just you can drag here different classes, add class customer, order, admin. If you want a new class, you can add a class like product. Then you want to execute a different class payment. You can add a class payment. Then one more class shipping. Then we need to identify each class's attributes and the relationship between the classes. So for if you consider the class customer, just make a right click and say add attributes. As we are making an analysis model, still we are not inserting methods to it. So for the customer class, add attributes like first is name. Here you can make the different visibility like plus indicates the public, minus indicate the private, hash indicate protected, and tilde indicate package. So you can make the private visibility to the name attributes. Generally we put a private visibility to the attributes. If you want to add more attributes, you can add after name the address. Again click on the visibility, you can make it public or again private, make those corrections. Add one more attributes by clicking right click. You can say email, as we are implementing the online system. Email is one of the important attributes of the customer class. You can add more attributes. You need to check as per your data dictionary how many attributes you have defined for the particular class. You can put After address, the phone number, contact details, make it private. Now, if as per our diagrams, we are making it customer with the particular register login ID. So you can put ID and password. These are the attributes of the customer. You can select here the visibility. So this is your customer class. Then you need to define the order class and relationship between the customer and a order. So basically, you can drag here easily order class. What are the attributes for the order class? We need first the order ID. Order ID. And make the private. You can add one more attributes for the order, that is quantity. For any order, these are the important. You can add as many attributes as you can. I'm adding very basic order here. You can add a quantity order, then name of a particular product. You need order name also, or you can define it as a product name. So if you want, you can define it as a P name. Take any order or a quantity. You can put some different name for the order. After that, you require the price and a date of the order. So you can set as a total price. You can put private, add one more attributes. After price, you need the status, that is order status, whether it is deliver or not. You need to put these attributes also, make a private. So you can observe here, if you select these are the name, address, email, phone and ID. I want to select the different check here between the customer and order. We'll check what is the relationship exists. It is the aggregation relationship, rather it is a composition. It is a compulsory relationship. So you can draw here the composition arrow, and from order to customer places. So obviously, what is the relationship? Customer places order, and it is the aggregation type of composition type of relationship, and you can assign here the multiplicity. If you click on a double click on the composition arrow, you will select the multiplicity. So from the customer, it may be one multiplicity, but for the order, you can select here it may be one to many type of relationship. So between a customer and order, you can place the relationship one to many. Similarly, you can add the Admin attributes, as admin is at the level of website. So basically you can add attributes to the admin, that is the ID and a name. You can put ID and name. You can, by default it comes as a public visibility. If you want to make, you can select it and make a private visibility. Then between a customer admin and one more class is the product class. The product class you can add the attributes like product name, name, then add one more attributes like PID, then we can add attributes of P type, if it may be a type of product. We can add attributes like description, quantity, so one after another you can add many attributes to the product. Then between a customer and a product and an admin, there one more class exists, that is the class of cart shipping. So if you go with the detail, you need one more class shipping, which has the attributes like again the name, which fetches the value of a product from the product name, again which fetches the value of the quantity from the product itself. So there is a aggregation kind of a relationship between a cart and a product. So we put the aggregation relationship here because product comprising of a cart. You can put a in cart total quantity, product may be many, which is selected by the customer quantity. Total quantity, total price, so you can add number of attributes. Total price. So between a customer and a cart, there is a relationship. Each customer has a card. It's an online system, so you can put a composition because this is almost a compulsory kind of a relationship. And you can put a multiplicity here, like you can say customer may be one to many, and for each of the for them card also maybe one to many. Then after the relationship between cart and a product, you can see here it also exists from one card to many. You can put here it may be one or product maybe many. You can say one to many. Again for admin and a product there is a relationship we need to put. This is the relationship between cart and a product contains, because cart contains product. While between an admin and a product, what is the relationship? It is the normal association between a cart and a product and admin association. So you can just click here the association relationship between a admin and a product. You can select multiplicity for each and every label. For the multiplicity between admin and a product, always 1, admin is 1, product may be many, 1 to many. And you can write the name of the associations like manages, admin manages products. So this is related to the customer card order. After that, you can see order consists of a payment and a shipping. Again, two relationships we can show here, the generalization. So shipping we can connect with the generalization, and payment also connect to the order with the generalization. So for the shipping and the payment, we can add some of the interfaces and the attributes. So attributes for the shipping, we can see ID. We can add more attributes and status. Shipping status. Then for a payment, we have again attributes like mode of the payment and price. So this is the relationship between order, shipping, payment. After that, if you want to go further, payment has a different mode. You can show with the generalization relationship that create the classes like different payment mode. You are having cash on delivery, different mode you can put cash on delivery, or you can put, as already we have discussed in the use case diagram, we are having net banking, Vim UPI. You can create number of classes. Net banking, how many more you want to show, that all you can connect here. You can say credit card, and you can show the this generalization relationship between the payment mode, and you can give all the attributes and operations. So cash on delivery, net banking, credit card, one more you can see UPI. So as many as you trying to connect it with the generalization solution. While trying to be sure that you connecting exactly. So try to connect with this. So I save the state. Okay. So this is the generalization relationship. If you want to create the interface of a particular order, you can connect the enumeration status of interface. So you can create here interface like order, order status. You can connect with the order. So you can show the simple interface. Also you can create the interface for shipping status. So order status you can have a different class, or shipping status you can connect to the interface, or you can add enumeration. This I want to show one more operation. Enumerations give you a stereotype where you can check the shipping status. Shipping status. So in which state your shipping is, you can add the enumeration literal, like in transit state. Then you can add one more enumeration literal, deliver, deliver, or return. So it keeps track of your shipping status. You can add enumeration also, you can add interface also, order status. For order status you can add also this enumeration. So you can connect it. So this is regarding your analysis class diagram. Remember, we haven't generated the design class. Then if I want to generate the code, there is a facility available in StarUML to generate code in C++ or Java for a given class diagram. So you can just, for generating a code, you can click on the tools, then go to Java and say generate code. So you need a generate code, you need that Java must be plugged in to the system and it is running on your machine, so that you will get the code with it. So you can directly click tools and go to generate code. You will get the Java code of a given class type. So this is related to your assignment number 4 analysis class model, and for the implementation go to tools, click on Java, generate code. You will get the implemented code snippets in Java. This is your assignment 4.